Good day everyone, we are now in quarter 4 week 2 of Mathematics 8 and it is entitled Applications of Triangle Inequality Theorem. Now, are you ready? So we only have one objective, it is to apply theorems on triangle inequalities. Without further ado, let us now start by using an example. So two sides of a triangle have the measures 6 and 7. Now, let's find the range of the possible measures of the third side. So, let us solve. So, let x be the length of the third side of the triangle. Then, according to the theorem of triangle inequality, which we tackled in the previous video, if the sum of the lengths of any two sides is greater than the third sides, then the given sides will form a triangle. So the sum of the length of the two given sides is 6 plus 7, that is equal to 13. Because the sum of the lengths of two sides 6 and 7 is 13, the maximum length of the third side must be less than 13. That is x is less than 13. Now let us find the minimum value of x. Based on the theorem, x plus 6 is greater than x plus 7, it is greater than 6. So to satisfy these inequalities, the value of x must be greater than 1. So that is x is greater than 1 or 1 is less than x. And therefore, the range of x is 1 is less than x, but x is less than 13. Another example. Find the range of the possible measure of x in the following given sides of a triangle 10, 7, and x. So the sum of the length of two sides, 10 plus 7, that is 17. So because the sum of the lengths of two sides, 10 and 7, is 17, the value of x must be less than 17. So that is x is less than 17. And the minimum value of x, it should be x plus 10 is greater than 7. Or x plus 7 is greater than 10. To satisfy both inequalities above, the value of x must be greater than 3. How do we get the value of 3? So we will just solve for the value of x in the equation or the inequality above. So x plus 10 is greater than 7 and x that should be greater than 3. So that is x is greater than 3 or 3 is less than x. So therefore, the range of x is 3 less than x and x is less than 17. Now, another example. If the three sides of a triangle are given by x plus 2 and the second side is 2x plus 7 and the third side is 4x plus 1, what is the greatest possible value of x? So, let's now solve. So, the quantity x plus 2 plus the quantity 2x plus 7, it should be greater than 4x plus 1. So 3x plus 9, by combining the two sides, it should be greater than 4x plus 1. Now, by combining the like terms, 3x minus 4x, it should be greater than 1 minus 9. And negative x, it should be greater than negative 8. Then let us divide both sides of the inequality by negative 1 and take note when we are dividing negative numbers, so the inequality will change from greater than, it will become less than, and therefore x is less than 8. Now let's check for the other side. How about we will add x plus 2 and 4x plus 1, so it should be greater than 2x plus 7. Now combining like terms, 5x plus 3, it should be greater than 2x plus 7. Then, 5x minus 2x, it should be greater than 7 minus 3. 5x minus 2x, that is 3x, and 7 minus 3, that is 4. Then let us divide both sides of the inequalities by 3 to get the value of x. Therefore, the value of x is greater than 4 over 3. Now, how about we add 2x plus 7 and 4x plus 1, and it should be greater than x plus 2. So combining like terms, so 2x plus 4x, that is 6x, 7 plus 1, that is 8. It should be greater than x plus 2. Then 6 minus x is greater than 2 minus 8. And 6 minus x, that is 5. 2 minus 8, that is negative 6. Therefore, 5x is greater than negative 6. Then, to find the value of x, let us divide both sides of the inequalities by 5 to come up with an answer. X is greater than negative 6 over 5. Therefore, 4/3 is less than x, and it is less than 8. So the greatest possible integer value of x is 7. Now, how about this problem? Given 5 sticks of respective lengths, we have 1, we have 3, 5, 9, and 10. How many distinct triangles can be formed from 3 sticks or from 3 of the sticks? So if one side of triangle has a side length of 1, then there is no possible combination to form a triangle. In fact, if the 3 sides of a triangle have distinct integer length, then it is impossible to have one side of unit length. So if one side has a length of 3, then the only possible combination is 3, 9, and 10. So if one side has a length of 5, the only possible combination is 5, 9, and 10. If one side has a length of 9, the possible combinations are 9, 3, 10, and 9, 5, 10. So if one side has a length of 10, then the possible combinations are 9, 10, and 3, and 10, 9, and 5. Since changing the order of the side doesn't change the triangle itself, we can form 2 distinct triangles with the sides 10, 9, and 3, and 5, 9, and 10. And that's all for the Mathematics 8 Quarter 4 Week 2 of Grade 8 Mathematics. So again, this is Sir King, and let us thank SDO Tarlac Province because their compendium of notes is our reference for this video. And that's all. Stay safe and stay sane. Goodbye everyone.